Okay, in this video we're going to do the 5.5 law of sines, and this is kind of the part one of it. So first off, I want to tell you that so far we have been doing Sohcahtoa, which is based exclusively on right triangles. Okay, you cannot do Sohcahtoa to either find a side or find an angle using inverse trig if you don't have a right triangle. That is key. Okay, so we're going to learn about law of sines, and you can use law of sines when you have a right triangle, but most people do not use it then. You generally use law of sines when you don't have a right triangle and you're trying to find either an angle or a side. And you've been given two angles and a side. Okay, that's key. You have to be given two angles and a side. Before we get into the specifics, let me show you how we can show that law of sines kind of builds upon Sohcahtoa. Okay, so a lot of the exercises I do here, you want to draw your triangles exactly the same way. Not because the way I do it is perfect or the only way to do it, but so that your angles and your letters and your small letters match with mine so that you can understand the explanation a little bit better. Okay, so the first thing we're going to do is we're going to draw a triangle that's not a right triangle. So let's get that piece going. So here is my non-right triangle. Okay, I'm going to label this A, B, C. And I'm going to do it in the same way I did these notes in class. Okay, next, I'm going to label the sides. So the side opposite capital A, which is the angle, is little side A. The side opposite capital B, which is the angle, is little side B, and that goes through all of this. And the side opposite capital C, which is an angle, is little side C. Okay, the next thing we're going to do is we're going to drop an altitude. An altitude comes from the vertex and makes a right angle on the side opposite it. That that altitude is frequently called height. So I'm going to make it an H for height. Okay, not for hypotenuse, but for height. So let me just write that up here someplace. So H equals height. All right, let's see if we can tie together Sohcahtoa and law of sines. So doing Sohcahtoa, I'm going to focus on this triangle first. Okay, so I'm focusing on the yellow triangle. And so from the yellow triangle's point of view, the sine of angle A equals opposite, which is that height, over side C, which is the hypotenuse of that smaller right triangle. Okay, so given that, if you were trying to solve for H, you would do cross products. So H equals little c times the sine of big A. Okay, let's focus on the second triangle. That's this guy right here that I'm highlighting in orange. Okay, so I'm going to put a little orange dot. And let's see if we can also find a sine feature. The sine of angle C, so angle C is over here to the right. Okay, we've looked at these two angles, A and C. It's going to equal opposite, which is H, over hypotenuse, which is A in this case. So let's see if we can isolate the H. H is going to be, using cross products, A times the sine of angle C. Okay, so let's think about this. What I'm noticing is that both of these equations are giving me a value for H. So I could prove that this works by taking those two equations and setting them equal. So since h equals c times sine A, and h also equals a times sine A, it therefore is reasonable, and I'm going to change my color perhaps, to say that c times sine of A equals a times sine of c. Okay, let's do some manipulating. And we're going to follow the rules of algebra in doing it. All right, I'm going to get temporarily sine A by itself, so divide by c. Whatever I do on the left, I must do on the right. Let's get sine c by itself. I'm going to divide by a. Whatever I do on the right, I have to do on the left. So let's look and see what I got as a result. Sine A over A equals sine C over C. Does this look familiar? It should look like parts of the law of sines. So we could go on and continue exploring the law of sines, or at this point you can just take it as a given that I built it from the law of from Sohcahtoa, which applies with right triangles, and I discovered a formula that now will help me solve a non-right triangle like triangle ABC. Okay, so that's a little background. I'm not going to ask you to prove this, but I wanted to have you think that we just didn't pull this out of whole cloth and just kind of made this thing up. Okay, mathematicians have kind of worked all this out, and you just got a little tiny insight into the way mathematicians work out formulas. Okay, so let's keep going. So I did talk about when you can use the law of sines, and this first case we're going to explore is if you have one side and two angles. So if you're going to prove congruency, you would do it either by ASA, which is angle, side, angle, or side, angle, angle. All right, so that means that in either case, you are given two angles and you're giving one side. Okay, so this is an example. Here's a side, here's an angle, here's an angle. So let's see if we can use this. So given triangle ABC, so I'm going to sketch out another triangle. And again, the way that the triangle is drawn is important to the interpretation. Okay, so get yourself an ABC triangle that looks kind of like mine. And then it is key, oh sorry, let me fix that. It is key that you label it the same way I do. So this is A in my sheet, this is B, and this is C. That makes this little c, this little b, and this little a. Okay, so let's see what they gave us. So I'm going to write the given stuff in green. So angle A is 63 degrees. Angle B is 49 degrees. And little side C is 78. Not degrees, just the length. All right, so I do indeed have two angles and a side. If I have two angles and a side, I'm going to use law of sines. So let's see how we're going to get started. We need a pair. We need to have an angle. We need to have the sine, the length of the side opposite it. So angle C is missing. But angle C I can get knowing that I have 180 degrees in a triangle. So subtract away twice the two angles given, and that gives you an angle of 68 degrees. Okay, so 68 degrees. I'm going to write that in red inside so that you know it came from a calculation. It was not a given. Okay, so I need to find each of the missing sides. I now have all three angles. So get your pairing. And my pairing, so let me change this back to a different color. So my pairing is going to be the sine of 68 degrees over the length of little c. So I have angle C and I have little c. That is a proportion that I need for the rest of this problem. That proportion will equal the sine of 49 degrees over b. So don't grab your calculator yet. What you're going to do is set up your equation. So I want to put things in my calculator only once. Otherwise, I'm going to have a partial, an early rounding issue, and I might not get a good answer. So let's do our cross products. And to do this, we're going to say, well, here, I'm going to draw them out for you first so that you know what I mean by cross products. Then you have fraction equal to fraction. You have that product equals this product. So it's called the product of the means equal the product of the extremes. Okay, so let's write it out. 78 times the sine of 49, close those parentheses, equals b times the sine of 68, close those parentheses. Your goal is to get b by itself because that's my missing side. Okay, this is a 1, so that cancels. Okay, so in my graphing calculator goes this expression. 78 times the sine of 49 divided by the sine of 68. And that should lead you to saying that b equals 63.5. So let me write that in red so that you see that we have calculated that. Okay, so that's one missing side. I'm going to write smaller and let's do the other missing side. So I'm still going to use sine of 68 over 78, and that's going to equal, let's find side A, sine of 63 over A. Cross products, right? This times this gives me A times the sine of 68. That's going to equal 78. And remember, it's good form to close those parentheses after your angle. 78 times the sine of 63. What goes in my calculator? Divide this by sine 68. Divide this by sine 68. Close parenthesis. That cancels. Okay, this is what goes in my calculator. 78 times the sine of 63 divided by the sine of 68. It goes in one step. Don't do it in two steps. You're going to do some premature rounding. Okay, so A, I'm getting to be equal to 75.0. I'm going to write it right here. So now you can see that we have found two missing sides and one missing angle. So we have solved the triangle. Okay, let's go on to the next example. Okay, so this application lets us have these 2 points, and they're points P and Q, and they run along a fence that are separated by 140 feet. So get yourself a nice triangle. Remember, it's not a right triangle, so don't make it look like one. And I'm going to label this P and this Q. This, remember, is on a fence line, and the distance between P and Q is 140 feet. Then they tell you you have a river that's passing through this triangle, and on the other side of the river, you have a flag. So I'm going to make that point F. Then they go on to tell you the angle formed by the fence and the line from point P to the flag measures 79 degrees. This is 79 degrees. The angle formed by the fence and the line from point Q to the flagpole measures 58 degrees. What are the distances from P and Q to the flagpole? So they want little q and they want little p. Okay, remember that little p's across from big P and little q's across from big Q. Okay, the first thing you've got to do is get your missing angle. So I get that by subtraction. So I'm going to say 180 minus 79 minus 58. And I'm going to get an angle of 43 degrees. Okay, 43 degrees. So I'm going to make this red, and I'm going to make this angle 43 degrees. Okay, so now we're going to set up our ratio. So let me, I'll change to blue to do our ratios. And there is a relationship between side F and the side opposite it, which is going to be little f. So this is little f right here. So this is a ratio that I need. So I'm going to say that the sine of 43 degrees over 140, that's the pairing I need, equals, so let's solve for a missing side. How about if we do the sine of 58 over Q? Okay, so do your cross products. Q times sine 43 equals 140 times the sine of 58. Divide both sides by sine 43. This expression goes into your equation, into your calculator. Oh, by the way, I should really stress, your mode should be in degrees, and we're going to round this to 1 decimal place. Okay? So, next thing. This goes in your calculator, as I said, and what you get out is that Q is going to equal 174.1. So I'm going to change to red, and Q is 174.1. Okay, time to find P. So let's change our color slightly. We are using the same ratio that we started off with, sine 43 over 140, but now we're going to find side P. So I'm going to say sine 79 over little p. Do your cross products. P times sine 43 equals 140 times sine 79. Divide both sides by sine 43. That becomes a 1. This goes in my calculator in one step, and I end up getting that P is going to be 201.5, and I'm going to write it right here. So we can see that we, once again, have solved for a missing angle and 2 missing sides. We had to do the missing angle first in order to get this starting ratio. That ratio or proportion is what got us going with law of sines. Okay, so let's go on to the next problem because there's some really important things coming forward. Okay, so let me slide this up. So this is a pretty straightforward problem. And what they're telling us is we have 2 angles of a triangle and they measure 38 and 87. Okay, so here is the triangle. Again, draw it so it's not a right triangle. So pick your sides. Well, actually, don't you pick. I'm going to pick. My angles are 38 in the corner here. and 87 in the corner here. I'm going to make this ABC and use the same lettering so we all match up. So that means this is little a, this is little b, this is little c. Okay, find your missing angle because that's always going to be key. So 180 minus 87 minus 38 is going to equal 55 degrees. Okay, that's my key factor. So I'm going to change to red and make this 55 degrees. Now I'm going to keep reading. It says if the longest side is 24. So they didn't say that A, B, or C is 24. They said the longest side. The longest side is always opposite the biggest angle. The biggest angle is 87, so therefore the longest side is little side C. So they gave us that information, but we had to kind of work it out. So this C side is 24. Okay? That's going to allow us to start thinking about solving this. So I do have an angle opposite that side. So get your ratio. Oh, and let me go on again one more time. Okay, the rest of the question says, find the length of the shortest side. Okay, find the smallest angle. It's here. So therefore, they want me to find A, which will be the shortest side. So I don't need to find B. Okay, I need a ratio of an angle to a side. So I have the sine of 87 over 24 equals the sine of 38. Remember, the trig word is always followed by the angle. Over little a. Okay, do your cross products. And divide both sides by sine 87. A is going to equal 24 times the sine of 38 divided by the sine of 87. That goes in your calculator all at once. I cannot stress that enough. If you do premature rounding, you're going to have a problem. Okay, when I plug this in my calculator, I get A is 14.8. And they only wanted A, so I am done. Okay, so what did I solve for here? I first found the missing angle. That allowed me to figure out which is the longest side and therefore get a ratio. And then I found the shortest side, which was opposite the smallest angle. Done. Okay, problem number 2. Let me change my numbering a little bit. So this should have been problem 3 right here. So let me make this a 3, and you can do the same. And then let's go to problem number 4, which says problem 3 with it. Okay, now this is a really good problem because it really goes through the intricacies of a right triangle and an oblique that is non-right triangle. And how do I figure out all these angles, and what do I use to solve each of the pieces of these triangles? So this is a really important problem, so make sure that you really concentrate on what I'm doing here. Okay, so I'm going to draw the triangle. From a point A, the angle of elevation to the top of a tree is 38 degrees. Okay, that sounds like a right angle trig problem, and it is. So that's a good thing because we're comfortable with that. So let me see if I can get my line tool to hop in. So get your line. That's your tree. Here's your right angle. Right here. And you can go ahead and complete this right triangle. Okay, so here's my right triangle. This is side A. This is my tree. and the angle of elevation looking up to the tree is 38 degrees. So don't forget about the angle of elevations. From a point 25 feet, closer to the tree, that means I was here, now I'm going to go here, and that's 25 meters closer, so that means this has to be 25. From a point B, the angle of elevation to the top is 48 degrees. So I'm going to go to the top, and I'm going to draw my straight line right down here. And now they tell me that this angle of elevation is 48 degrees. Okay. Before I start this problem, I have to find as many angles as I can. And that will be all of them. Okay, all of the angles is what I'm going to find. So if this is 48, I know that I can extend this semicircle, and a semicircle is 180 degrees. So I'm going to say 180 minus 48, and I'm going to get 132 degrees, and that is what this angle is right here. So I'm going to change that color. Let me write the things that I find in red so that you know it was not part of the original problem. Okay, so I got this angle of 132 degrees. Okay, next, look at this triangle. So we're going to spend our time for just a second on the oblique triangle. This is your oblique triangle, the one I'm highlighting in yellow. So the oblique triangle, just like any other triangle, has 180 degrees in it. So I'm going to say, I want that top angle. So say 180 minus 38 minus 132, and that's going to give me 10 degrees. Okay, so 10 degrees is the top of that triangle. Okay, so 10 degrees is the top of the triangle. I'm going to highlight that in red, and I'm going to write that in red. So this is 10 degrees. Okay, let's go into the right triangle now, because I might need some degrees there too. I'm just not certain. So in the right triangle, so this was, let me just highlight this in yellow too, perhaps. Okay, so this is what I did in the yellow triangle. Now let's go to the orange triangle, which is the right triangle. Okay, so I'm going to focus on the right triangle. So I know that 48 degrees and the missing angle are complementary. So 90 minus 48 degrees is going to give me 42 degrees. Now I may not need the 42 degrees, but you just never know. And we have the ability to solve for all the degrees, so let's go ahead and do it. And you know that this is 90 degrees right here. Okay, so let's now read what they want us to find out. How far is it from point B to the top of the tree? Okay, so I neglected to label point B, so let me do that now. So from point B to the top of the tree, I'm going to call this X. So the first step is to find X. Okay, so X is in the yellow triangle, not the orange triangle, but the yellow triangle. So I am going to use my law of sines to find X. So set up your ratio, because you have an angle and a side that are matching. So the sine of, what's your angle? It's 10 degrees over 25, which was the distance between A and B, equals, okay, what angle goes with X? You should be saying 38, sine of 38 degrees over X. So do your cross products. x times the sine of 10 equals 25 times the sine of 38. Divide by sine 10, divide by sine 10. And what you should be getting is your x value. And I got x to be 88.6 feet. Okay, so I need that number. So I'm going to write it on my triangle on that line right there. So x equals 88.6, okay, feet. Okay, next thing. How tall is the tree? So they want us to figure out how tall the tree is. So let's make that y, okay? The tree is y. Okay, the tree is in the orange triangle. Okay, so I should say this problem A was all in the yellow triangle, and that's why I had to use law of sines, because it was not a right triangle. Now I'm back in the orange triangle, so I can use Sohcahtoa. So I want to figure out what y is. I have some options. I'm going to use sine. So the sine of 48 equals the side I'm looking for, which is y, over what? Over the hypotenuse, right? Because sine is opposite over hypotenuse, and the hypotenuse we just found was 88.6. Okay, you've got a one-step equation, 88.6 times the sine of 48 is going to equal y. And I got y to be 65.8 feet. So let's write that on our triangle. So this is y, and that's going to be 65.8 feet. And to do that problem, I used the orange triangle, which was a right triangle, so I used Sohcahtoa. For the yellow triangle, I used law of sines because I did not have a right triangle. You may want to spend another minute or two on that problem because it is really key determining whether you're using a right triangle or a non-right triangle, because they have different ways to solve for them. All right, let's go on to the next problem, which we're going to make problem 5. So I don't believe it's numbered. So we've had problems like this before also. So this is the banner hanging down problem. So there's a 60-foot banner hangs down from the top of a tall building. Okay, so let's start doing some drawing. I'm going to make this my building. Okay, and then I'm going to say here's the banner, and it's hanging down. Okay, so we'll make it a color. So let's make it, we'll make it a blue banner. Okay, so here's your banner hanging down. Okay, so the building is part of a right triangle. So it says your angle of elevation to the top of the banner is 48 degrees. So get yourself a triangle. So I'm going to continue this, and then I'm going to draw my hypotenuse, because this is a right angle. Okay, so this is the building right here. And this is my banner. Okay, so the angle of elevation from the bottom of the building, from the ground to the top of the banner is going to be 48 degrees. So this entire angle right here is 48 degrees. Then it says your angle of elevation, to the bottom of the banner is 18 degrees. So why don't I grab a different color? And I'm going to go from here, the bottom of the banner, back to here. So that means that this has to be a straight line going right there. And that angle of elevation is only 18 degrees. So this is 18 degrees. And therefore, we can make sure that we know the other piece will be 30 degrees. Okay, let me just write this in blue. So this blue angle right here, that whole blue is 48 degrees, okay, from here to here. Okay, so we have some angles now. How far away are you from the bottom of the building? Okay, so you are standing here. So the question is, how far are you away from the bottom of the building, which is here? All right, do we have any other measurements? Yes, we know that the banner is 60 feet. Okay, that's going to be important. So right here, this is 60 feet. So that is 60 feet. Okay, so what else do we know? I have one angle inside. Do I know the top angle? And I think I do, because the top angle has to be supplementary with the 48-degree angle. Okay, so 90 minus 48 degrees equals 42 degrees. Make that red, and let me write it in red. So right here, this angle at the top is 42 degrees. So they want to know how far away you are. So what am I thinking here? I am thinking that it would be nice to find the hypotenuse. So if I can find this, let's make this y, then I'll be able to find z, which is what I really need. Okay, how am I going to find y? Well, do I have any other angles I can work with? I have the 30 degrees, so let's just try it. Let's first work in the yellow triangle. This is not a right triangle, right? And I'm going to try to find y. So let's see if I have a setup. And if I need to work a little bit in the setup, that's okay. So I know I have that 30-degree angle right over here, right? That's opposite the 60. So there's my pairing. So the sine of 30 over 60 equals, oh, look, I have the sine of 42. Isn't that across from the y? Yes, so that's fabulous. So now do your cross products. Y times the sine of 30 equals 60 times the sine of 42. Divide by sine 30 on both sides. Don't put this in your calculator until now. This goes in your calculator, and that will get me y. So I'm getting y is 80.3. Okay, so this is 80.3. Let me go back and make it red. So that's 80.3. And I'm going to write this in my little sketch here. So this is 80.3. All right, now could I get z? I bet I could. And so I did my first calculations on the yellow triangle, which was not a right triangle. So I had to use law of sines. So this was the first thing I did. We'll call that part A. Now let's go to part B, and I'm going to use the other triangle. And why don't we just shade this in orange And you can see that it's a right triangle. So I'm going to do all my work over here on that right triangle. And since it's a right triangle, I can use what? Sohcahtoa. So what do I know? Inside that orange triangle, I see I have an angle of 18. So I think I need the adjacent, and I have the hypotenuse. So that is cosine. So what I'm going to say is the cosine of 18 degrees equals adjacent, which is my z, over the hypotenuse, which is the connecting line between the two triangles. And then this goes in your graphing calculator. What goes in? 80.3 times the cosine of 18. That will equal z, and I'm saying that z is 76.4 feet. So we have both of our answers. There's z, and here is the value, 76.4. Okay, this is another important problem. Make sure you understand that. Okay, so we're going to go on to a different topic. And we may visit this again in another video, but I just wanted to go through an example of area. So we know that one equation for area of a triangle is something you learned probably in grade school. 1/2 base times height. What kind of triangle is that? That is a right triangle, okay? Because you have your base, you have your height. This is your height, this is your base. Okay, so that you can use in a right triangle. What if you don't really have like heights and stuff like that? If you don't have what you need, there's another formula that involves sine. And it is area equals 1/2. And instead of saying base times height, I'm saying AB times the sine of C. That's going to give me area. So let's figure out where this came from, because I'm not exactly sure where this came from. And I don't want to just say, oh, we can just do this. So let's make sure we understand it. So before we get into a proof of this, why don't we do a regular area equals 1/2 base times height problem with numbers. So if I want to find this area, and let's say I know that the base is, the height is 5, and the base is 12. If that is the case, my area is 1/2 base is 5 times 12, which is 60. That's going to be 30. Area is a squared unit. So why is that 1/2 base times height? Well, it's based on a rectangle, right? Isn't the area of a rectangle base times height? So if a triangle is half a rectangle, it makes sense that the area of a triangle is 1/2 base times height. All right? So now let's take that reasoning and apply it to a triangle that's not a right triangle. So let me get another color. We'll go for just basic black here for a contrast. So draw a triangle that is not a right triangle. Okay, there's a triangle that's not a right triangle. I'm going to label this ABC, so please do the same. Then I'm going to drop a height, also called an altitude, from B to the base. Let me get this to be a straight line. When it hits the base, it forms a right angle. Okay, this is the height or the altitude. So let's say they gave us some measurements. Let's say they told us this was 18, this was 22, and this was 26. Okay, so what do we know? I'm seeing that I have two right triangles I can work with. So let's start working with the right triangles. So I'm going to look at the triangle to the left. So I'm going to highlight this guy in yellow. So let's focus on the yellow triangle first. And I know from this angle's perspective, the sine of C equals opposite over hypotenuse. Okay, so then when I do my cross products, I find that H equals 18 times the sine of C. Okay, so let's think about this. Let's think about this. How can I relate this to what I'm doing? Don't I know that if I look at my formula, so the formula is right here, doesn't area equal 1/2 AB? So let's see. So let's think about this for a second. Okay, I think the simplest way to do this is to say, okay, normally, area of this triangle that I have right here is going to be 1/2 base times height, right? 1/2 the base times the height. Well, don't we know that this height can be expressed as 18 times sine C? All right, so let's think about that. So let me go back to area equals 1/2 base times 18 times sine of C. Okay, what else can I figure out from here? Okay, what's 18? Oh, 18's across from capital A. So isn't 18A? And what's the base? Well, look, the base, isn't that across from capital B? So wasn't that the 26? Okay, so let's think about this. Let me look at this formula up here, right here, and let's see if we can make these the same. 1/2 B times A times the sine of C. Okay, they match. So really, I can get this entire triangle without having to draw the height in if I use this area formula. So this is the new and improved area formula that I can use on a triangle like this that's not a right triangle. And I can use that formula without having to drop the height. Okay, so that's how this equation came about. So let's try to use this. Okay, again, I'm not going to have you show me the proof. I'm going to give you the equation every time, and you're just going to be applying it. But again, I didn't want to have you think that we just thought this up because it's a good thing to think up. Okay, here's some practice problems. Okay, triangle FGH, angle F is 75, H is 5, and G is 4. Okay, so it is very, very important that you draw these triangles to reflect what they're telling us. So let me do FGH. This is FGH is how I have mine oriented. This is 75. This is little h, which is 5. And this is little g, which is 4. And everything's in centimeters, so I'm good to go. Okay, so how can I relate this to 1/2 AB? Whoops, hold on. Okay, I'm sorry. My iPad died, so I'm back up and going again. I'm sorry this is so long, but hopefully you'll benefit from this instruction. So we're going to use this formula, the new and improved one. So we're going to use, and I'm hoping that my pen and everything continues to work. Oh, let's see. Okay, so let me stop this just for a second. I'll be right back. Okay, I'm going to try this one more time. So let's draw a triangle. So let's see if I can get this to disconnect. Okay, so I'm going to draw a triangle. It is FGH. Okay, angle F is 75. H is 5, and G is 4. So I'm gonna highlight something here for you. When you do this kind of calculation of area, what you want is this kind of sandwich where you have two sides and an angle. If you have that, then what you can do is you can find the area of the triangle by saying area equals 1/2, so side 5 times side 4 times the sine of the angle in between. And if you put this in your graphing calculator, or any calculator for that matter, you will get area equals 9.7. So 9.7, and it's going to be centimeters squared. Okay, let's do the next shape. And I apologize for my finger, but it's the best I can do right this minute. So look at this triangle. Here is F again, which is 105. This will be H. This will be G. Therefore, this is little h, and this is little g. You again have that sandwich situation where you have bread, jelly, bread. So 5, angle, 4. When you have that, you can figure out the area. It's 1/2 one side times the other side times the sine of 105. And when I did that, I curiously got the exact same value. Why is that? Well, look at those two angles, 75 and 105. So 75 and 105 are symmetry partners. They have the same value for their sine. Okay, they are, if you add them together, it's going to be 108 degrees. So this 75 would be the reference angle. 180 minus the reference angle is 105. Okay, so that's just a little aside. And let's do one last thing, which is right here. Adjacent sides of a parallelogram. Okay, so let's draw a parallelogram. Parallel, parallel. Not really the way I drew it. So let's make that parallel. Okay, parallel and parallel. That's a parallelogram. Adjacent sides of a parallelogram have lengths of 12.5 and 8 feet, not drawn to scale. The measure of the included angle is 40 degrees. Find the area of the parallelogram. Well, look what's going to happen. Connect these two lines. You have two triangles. A parallelogram, the opposite sides are going to be equal, and the angles across from each other are also going to be equal. So if you find this area, just double it, and you will get the area of the parallelogram. And look, you have the sandwich. So let's figure out my area. So area is 1/2, 12.5 times 8, and then times the sine of 40. If you put that in your calculator, you should be getting the area is 32.1. Okay, that's the area of the yellow. So the area of the entire thing, the orange, is going to be twice that. So the area of the orange equals 2 times 32.1, or 64.2, and it's in feet, so this will be feet squared. Okay, thank you for your patience. That ends this entire video, and it also included the area problems. I hope you found that helpful.